అదాన్ చేయలేము. So yesterday, so we have done with yeah. So yesterday we have done with integer data type. So I said integers are shareable and you can represent integers in different formats. So there are different formats in which you can represent integers. So there is a decimal integer and there is what? Octal integer. And there's one more which is called as hexadecimal integer. Now let us see how to represent in other formats. So let us see one more format in which you can represent integer value. So that is hexadecimal integer. So you can also represent integer value in hexadecimal format. So what is this? So what is this hexadecimal integer is? An integer value with base 16 is called hexadecimal integer. An integer value with base 16. So this integer consists of okay, digits from 0 to 9 and A to F. So this can be a small f or it can be what? Capital F. Okay. And this integer is prefixed with. Okay, this integer consists of digits from 0 to 9 and A to F. And this integer is prefixed with 0x or 0 capital X. So generally the larger values, okay, larger integer values are represented in hexadecimal. Larger integer values are represented in hexadecimal format. Larger integer values. What I'm telling you is larger integer values are represented in hexadecimal format. Larger integer values are, yes. For example is like, example is memory addresses. So memory address can be represented in memory address can be represented in which format? Hexadecimal. Suppose color values are represented in hexadecimal. Register addresses. So all these color values, register addresses, memory addresses, okay, all these are represented in which format? Hexadecimal. If the value is very large, larger values can be represented in hexadecimal. But hexadecimal integer is prefixed with what here? 0x. Either it is small 0x or it can be capital 0x. Small 0x or it can be capital 0x. Okay. Just try to understand this. So how, yes, how it is done? So for example, see, this integer is created with, this integer is created with all the digits from 0 to 9, 0, 1, 2, 3, 4. Okay, you can create with all these digits. Okay, there is a 10, 11, 12, 13, 14, and 15. What is the 10 equivalent of value? A, and this is B, and this is C, and this is D, and this is E, and this is what here? F. Okay, this is F. For example, assume that there is one integer. Okay, assume that there is an integer called, okay, assume that there is an integer value called 27. Okay, 27 is which value here? Decimal value. 27 is what? Decimal. But I want to represent this 27 in what? Hexadecimal. 27 is decimal. 15, yes. 49, this is 15. Mistake is done here. Now this value is what here? 15. Now I want to convert this 27 into decimal. So if I want to convert this 27 into hexadecimal. So how can I convert this 27 into hexadecimal? Divide with 16. Now if you divide with 16, how many times here? One time. One time, and what is the remainder? 11. What is the remainder here? 11. So it is nothing but 111. So 1, and what is the equivalent of 11? B. So 1B, okay, 1B is which one here? Hexadecimal value. 1B is which value here? Hexadecimal value of which one? 27. So 1, 11. 11 is the remainder, right? So what is the 11 equivalent of hexadecimal value? B. So 1B is what your hexadecimal equivalent of it. If you want to convert this hexadecimal again to decimal, what you can do? You can say 16 to the power of 0, this is 1. Now 16 to the power of 0 into B. B, what is the B value here? 11. Okay, plus 16 to the power of 1 into what is that? 1. Now this is nothing but 11 plus what is that? 16. What is the equivalent value? 27. Now this is converting decimal to hexadecimal, and again hexadecimal back to what? Decimal. So but hexadecimal consists of digits from 0 to 9 and A to F. 0 to 9 and A to F. If the value is very large, that value can represent in which format? Hexadecimal format. If the value is very large, then you represent in hexadecimal. It is like this. So for example, okay, suppose I'm saying z, yeah, some assume that n1 equal to 0x a. So 0x a, this is which value? Integer value only, but it is in which format? Hexadecimal format. And what is a equivalent of integer? What is a equivalent of integer? 10. So what is the decimal value of a? 10. Okay. If I try to say n1, what is n1 value? 10. If I want in hexadecimal, I use a function called hex. Hex of n1. Now this will display in which format? Hexadecimal. For example, if I'm saying hex of 27, 27 is what here? Decimal. And if I want in hexadecimal, what is hexadecimal of 27? 0x1b. Okay, hex of, if I'm giving some value, some 245, 245 is what here? Decimal. And what is the hexadecimal of 245? 0xf5. 0xf and 5. Okay. So if you want to convert decimal to hexadecimal or octal to hexadecimal, you can convert that by using one predefined function. And what is that predefined function? Hex, and it followed by value. So this function returns what? Hexadecimal. This function returns hexadecimal value of given what? Integer. Hex of value. This function returns hexadecimal value of given integer. Hexadecimal value of given integers. Okay, so there is one more way of representing integers. See, I said, like when you're working with, so where we can use this hexadecimal values. I said this hexadecimal values are used by operating system for generating what? Addresses. You can also use it for generating which one? Colors. For colors means, for example, I think if you know HTML, okay, in HTML, what do you do it? You'll try to say body. So I want to define the background color of the body. I'm saying body BG color. So I can represent this color directly as a red. I can represent this directly as what here? Red. Or I can represent this value in which format? Hexadecimal format. So where I can say some AA RGB. RGB means now full red. FF means what? 256. Last value. Okay, last value. FF 0000. If I'm writing like this, now this is one value, but this value is in which format? Hexadecimal. FF 0000. So that is RGB, red, green, and one more is what? Blue. Suppose FF is there. FF means what here? FF. What is this FF here? Now you try to convert this FF. So FF is in which format? Hexadecimal format. FF is in which format? Hexadecimal format. Then what is the equivalent of decimal value? Okay, this is at which place? 0 and this is at which place? 1. So F means what here? What is F indicates here? 16 to the power of 0 into F means what here? 15. And 16 to the power of 1 into 16 to the power of 1 into what? 15. 16 to the power of 0 into 15 is what? 15. plus 16 to the power of 1 into 15. Now that is 16 into 15. 16 into 15 is what? 240. Okay, 240. Then 15 plus 240 becomes what here? 255. Now 255 is complete red. 255 is what here? Complete red. Now 255, because you'll have maximum, the combination in red is from 0 to 255, which consists of 256 colors. Okay, each one, see, generally, how many colors will be there? Only 3 colors will be there: red, green, and blue. You combine these 3 colors. You combine these 3 colors to generate one new color. You combine these 3 colors to generate the new color. Now here, when I'm working with colors, when I'm working with the colors, I may represent these colors in which format? Hexadecimal, because it is very larger value, and you make this value as a small by using which one? Hexadecimal. I can write FF. FF means what here? 255. What is FF? 255 means maximum color in red. Okay, maximum color in red, maximum color in red, maximum color in what? Green. So maximum color in red, maximum color in what? Green. You are mixing these two colors, red and green. If you mix these two colors, red and green, you'll get one color. But how I'm representing this value in hexadecimal format? Okay, so the larger values, what I mean to tell you is the larger values are represented. Larger values are represented in which format? Hexadecimal format. Okay, yes. So there is one more format in which you can represent integer value. There is one more format in which you can represent integer value, and that is which one? Binary integer. Binary integer. An integer value with base 2. An integer value with base 2 is called binary integer. An integer value with base 2. An integer value with base 2 is called a binary integer. An integer value with base 2 is called binary integer, and this integer consists of digits, 2 digits. Okay, 2 digits, that is 0, and one more is what? 1. And this integer is prefixed with 0b or 0 capital B. So this integer is prefixed with 0 small b, or it is prefixed with 0 capital B. This integer is prefixed with 0 small b, or it is prefixed with 0 capital B. This integer consists of 2 digits. One is 0 and one more is a 1. And this integer is prefixed with 0 small b or 0 capital B. Yes, it allows only 2 digits. One is 0 and one more is 1. But when you represent integers as zeros and ones, for example, when you're working with electronics, if you are working with low level programming, example is when you're working with electronic circuits like logical gates, when you're working with what here? Logical gates. And not only that, okay, logical gates. Example is when you're working with logical gates, And it is also used for memory management. It is also used in what? Memory management. So why? Because in memory always the data will be stored in which format? Okay, in memory always the data is stored in which format? Zeros and ones. In memory always the data is stored in which format? Zeros and ones. So the integer which is prefixed with 0 small b or 0 capital B, so that integer is called which one? Binary integer. For example, see what is a logical gate? Okay, it is an it is a it is a mediator through which you send inputs like zeros and ones, where you get one output. Okay, so which is used in electronic circuits, right? And not only that, it is also used in what? Memory management, because internally always the data is stored in which format? Zeros and ones. For example, okay, for example, there is one value. Assume that there is a value called 45. So what is 45 here? Decimal. 45 is a decimal. And what is the binary equivalent of this 45? So what you're trying to do is you're trying to convert this 45 into what? Binary. Means you have to divide with the base. So how many times here? 22 times. And what is the remainder? 1. And 2, how many times here? 10, 11 times. And remainder is a 0. And how many times here? 5 times. And remainder is what here? 1. And how many times here? 2 times. And what is the remainder here? 1. And how many times here? 1 time. And what is the remainder here? 0. So what is the binary equivalent of this? 1 0 1 1 0 1. 1 0 1 1 0 1. And this is in which format? Binary format. Okay, so always the binary is prefixed with what? 0b. Okay, now this is converting decimal to what? Binary. Then you can convert binary back to what? Decimal by multiplying with what? 2. Now this is at 0, this is at 1, this is at 2, this is at 3, and this is at 4, and this is at what? 5. Now 2 to the power of 0 into 1 plus 2 to the power of 1 into 0 plus, okay, 2 to the power of 2 into what is that? 1 plus 2 to the power of 3 into 1 plus 2 to the power of 4 into 0 plus 2 to the power of 5, okay, 2 to the power of 5 into 1. So this is nothing but 0 into 1 becomes what here? 0. 0 plus 0 plus 4 plus what is that? 8. Okay, plus 0 plus 32 plus what is that? 32. 1. Yes, this is 1. Okay, 1 into 1 is 1. So 32 plus 8 is what? 40, 44 and 45. So here 45 is which value here? Decimal value. So this is converting decimal to binary, and again converting binary to which one? Decimal. Again converting binary to decimal. Okay. But default representation of any integer is in which format? Decimal format. But when your application required, then you try to represent in different formats. So that can be binary format. Okay. Yes. For example, I'm writing n2 equal to 0b 101. 0b101. What is the n2 value? 5. But I want this should be displayed in binary format. Then I can use a function called bin. So here bin is a predefined function that will return the value in which format? Binary format. Okay, by default, it doesn't display in binary format. For example, if I'm saying binary of 65, 65 is which value? Decimal value. So that will return binary of it. Okay, if I'm saying 0xa, 0xa is which format? Hexadecimal, which you are converting into what? Binary. So 0xa means what? 10. 10 equivalent of binary is what? 1010. If you want to convert, you take the help of which functions? Type conversion function. If you want to convert, you take the help of which functions? Type conversion functions. Okay. Yes. So how many in how many formats can you represent integers? Four formats. One is a decimal. Second one is octal. Third one is hexadecimal. Fourth one is binary. But what is the default representation of integer? Decimal. But when will you represent in hexadecimal if the value is very large? When will you represent in binary format if you want to deals with memory? If you want to deal with memory and if you want to represent it as zeros and ones, then we can go for binary format. Okay. Yes. But I say no, integers are immutables. Integers are what? Immutables. Because of immutables, they can be what? Shared. Because of immutables, they can be what here? Shared. For example, I'm writing a equal to 10 and b equal to 0, b 1010 and c equal to 0x, 0x a, 0x a and d equal to 0 o, okay, 0 o and what is that? 12. Now tell me how many variables are there? Tell me how many variables are there here? How many variables? Four variables are there. What is that variables? A, B, C, D. Okay. But these four variables hold how many objects? Okay. How many objects? How many objects? Only one object. How many objects here? One object only. How many objects here? One object. So why? Because it will create, suppose A equal to 10 means it will create an object with the value what? 10. It will create an object with the value 10 and assume that address of this particular object is 1000. Now A is a variable and this variable hold always in Python variables are which variables? Reference variables, and reference variables hold what here? Address. Now I'm saying B equal to 0B1010. 1010 is which one? Binary. This is which one? Binary. But if you convert this binary into decimal, for example, if I'm saying print, okay, print is 0. If I'm saying 0B, 0B1010, or I just write, what is that? B equal to 0B1010 and B means what is the value of B here? 10. Is it 10 is already there or not? Yes. So if it is exist, will it create it or will it share the same value? Will it create it or share the same value? Share the same value. It will not create it. It will share the same value. Now B is also pointing to the same object or not? Yes. Now when it says C equal to 0xa, C equal to 0xa, C equal to 0xa. So A, what is A equivalent of decimal value? 10. Is it one more variable is created? And this variable, is it also pointing to the same object or not? Yes. So A, B, C are three variables, but these three variables holding address of same object or different object? Same object. Because integers are immutables and they are shareable. And 0 or 12, 0 or 12 is what? Octal format. So octal to decimal means you have to say 8 to the power of 0 into 8 to the power of 0 into 2 plus 8 to the power of 1 into 8 to the power of 1 into what? 1. It's nothing but this is 2 plus 8 and 2 plus 8 is what here? 10. So is it 10 is already there or not? Yes. So is it D is also pointing to the same object or different object? Same object. So total how many variables are created here? Three variables. And these three variables are pointing to the same object or different object? Same object. So that is where I said integers are immutables. Because of that immutability, they can be what here? Shared. Because of that immutability, they can be shared. Okay, but when you are working with a shell, now this is a shell, right? You are working in which mode here? Interactive mode. This is what here? interactive mode, or it is called as which one? Shell. You are working with the shell. You are working with the shell, or you are working in which mode? Interactive mode. It is a shell. The same thing you call it as what? Interactive mode. And shell will not have all the features. Shell will not have all the features. For example, if you are working with a shell, I'm saying here x equal to some 255, x equal to 255 and y equal to 255. How many objects are created? How many objects are created? How many objects? One object. And how many variables? Two variables. Okay. One object and two variables. Okay, you can see that x value is what? 255. Y value is what? 255. ID of x, print the ID of x and print the ID of which one? Y. Is it address of x and y both are same or different? Same. Because is it both are sharing the same object or not? Yes. If I'm writing a equal to 256, a equal to 256 and b equal to 256. So how many variables are there here? Two variables. And then how many objects here? Then a value is 256 and b value is 256. And I'm trying to say ID of a and ID of what here? B. Is it address of this both are same or different? Same. Suppose if I'm writing n1 equal to 257, n1 equal to 257 and n2 equal to 257. So is it how many objects are created here? How many objects are created here? One object. And this one object is shared by how many variables? Two variables. What is the value of n1? 257. What is the value of n2? 257. ID of n1, ID of n1, ID of n2. Is it ID is the same or different? Is it address is the same or different? Different. Means how many objects are created? One object or two objects? No. ID is the same or different? Is it ID is the same or different? Different. Means one object is created or two objects are created? Two objects are created. But what I said, integers are shareable or not? Yes. But this is when you are working with a shell. Okay, shell, right? This is about which one? Shell. When you're working with a shell doesn't have all the features. It means whenever you open ideally shell, just try to understand this concept here. This is related with only shell, not related with the Python. According to Python, integers are what? Shareable. According to Python, integers are what? Shareable. But I'm talking about which one? Shell. When you are working with a shell, when you open the shell, right? When you open the shell, shell is a program or not? Yes, shell is one program which allows you to work in which mode? Interactive mode. When you open the shell, right? When you open shell, okay, when you open shell, okay, this is a shell. When you open the shell is a program. Shell is a program. And when you open the shell will have predefined integer object pool. Predefine integer object pool. Predefine integer object pool. Means whenever you open the shell is created with some predefined integer objects. Okay, so how many objects will be there inside this, whether you are using it or not using it? Okay, it will try to create how many integer objects here? It will try to create some 256 integer objects, 256 integer objects. It will try to create total how many objects here? 256 integer objects. Now, whenever you are saying here, whenever you are writing here n1 equal to 10, the shell is looking for which object? 10 object within the pool. Is it 10 object is there in the pool? Yes. Then what will it do? It will just assign it. Okay, it will just assign it. It means what is the maximum size of integer pool related with the shell? 256. What is the maximum size of this pool in shell? 256. 256. How many objects are there inside this? 256. Now, when you say n1 equal to 10, 10 is already there in the pool or not? Yes, it will just assign it. If I'm trying to say n2 equal to 65, is it 65 is there in the pool or not? Yes, it will assign it. If I'm saying n3 equal to 65, is the 65 is there in the pool or not? Yes, it will assign it. If I'm saying n4 equal to, if I'm saying n4 equal to 100, is it 100 is there in the pool or not? Yes, assign it. But if I'm saying n5 equal to some 280. Okay, if I'm saying 280, is it any object with the value 280 is there in the pool? No. Then what will happen? It will create outside the pool. It will create where? Outside the pool, outside the pool, outside the pool. If it is created, is it shareable or not shareable? Not shareable. If it is created outside the pool, is it shareable or not shareable? Not shareable. Okay. If you are writing again n6 equal to 280, is it 280 is there in the pool? No. Then what will happen? It will create one more object with a value 280. Okay, it means how many objects are created here? Two objects. But is it having same value or different value? Same value. But this is only related with the shell. You don't require to think about this. But if you are working in programs, applications, if you are working in a program, how you write a program? How you write a program in Python? You write a program in Python, go to file and select what? New file. Go to file and select new file. Now here I'm writing n1 or I'm writing x equal to 258 or 257 and y equal to 257, and I'll try to print id of which one? X, and I try to print id of which one? Y. I try to print x value as well as what? Y value. Now, when you're working with the programming mode, who execute your Python program? The Python program is executed by Python virtual machine. Python virtual machine. Now, Python virtual machine, will it provide all the features or not? Yes. Now, just click on run and run module. See here, is it displayed with the same address or different address? See here, is it displayed with the same address or different address? Same address. Means is it integers or shareable or not? Yes. But when you are working with ideally is only for development purpose or practicing purpose. Practicing purpose, not for development purpose. Developing means you'll try to write everything in which mode? Programming mode. A program. This is a program. And this program is compiled and executed by Python virtual machine. So how many objects are created here? One object or two objects? One object, and one object is shared by how many variables? Two variables. Now somebody is asked yesterday in the Google Classroom this. Okay, somebody is given like this. So 1500 n2 equal to 1500 and put a question. I'm not getting the same ID. Is it same ID or different ID? Different ID. But when you write a program, what is this value here? 1500. And what is this value here? 1500. What is this value here? 1500. And if you run this, is it ID is the same or different? Same. Okay. So because of this shell is able to hold, shell is having one predefined, shell is having one predefined integer object pool, and that predefined integer object pool is having how many objects total? Total how many objects are there? 255 objects, 256, that is 0 to 256 objects will be there. So whenever you create object, you just assign it. But if you create an object which is more than 256 value, that will be created where? Within the pool or outside the pool? Outside the pool. If anything is created outside the pool, is it shareable? No. That's the reason it is creating how many objects here? Two objects. But this is only related with what? Shell. But you know, don't work with what? Shell. You work with the programs. Programming mode. Just try to write a program and execute it. So that you'll get the same address. So that you'll get the same address, but rather than what? Different addresses. Okay. How you write a program? If that is the case, then tuple address is different, integer address is different, right? If that is the case, right, that question is, if that is a question, one is a tuple address is different and integer address is also different. Okay. So this is one more thing which you have to remember here. Okay, this is one more thing which you have to remember. Okay. Yes. See, tuple is different and integer object is different, right? So how it is shareable? Not shareable, right? Okay. So this is how you are trying to represent which values here? Integer values. Now let us see one more data type. Let us see one more data type. And what is the data type here? Float. See, you don't have more number of data types. Okay. You don't have more number of data types. Only, okay, numeric data types are only three: integer, float, complex. How many types of numbers are there? Three types. Okay. Integer numbers, real numbers, complex numbers. In mathematics point of view, integer numbers, real numbers, and one more is what? Complex numbers. Integers, which doesn't have any decimal point. Whole numbers, natural numbers, even numbers, odd numbers, all this comes under which type? Integer type. Real numbers. So real numbers are numeric values with what? Decimal point. Okay. In computers, you'll say it is a float. Okay. So float value, float data type. Now float data type is used to represent which numbers? Real numbers. Float data type is used to represent real numbers. Real number. A numeric value, a numeric value with what is that? Decimal point or precision. Decimal point or precision is called which number? Real number, or it is called as floating point number, or it is called as which value? Float value. A numeric value with decimal point or precision, a numeric value with decimal point or precision is called a real number or floating point number, or what? Float value. For example, you want to represent pi value. How you represent pi value? You'll say pi equal to 3.147. So yeah, this 3.147 is which value? Float value. This 3.147 is which value? Float value. Suppose you want to represent the radius. You want to represent radius of circle. Radius of circle, I'm trying to say radius equal to 1.5. So this 1.5 is which value here? Float value. Okay. I'm representing 3.147 is a float value. 1.5 is also which value? Float value. So how you represent this? By using which data type? Float data type. Okay. And all these are immutables. Float is immutable. Integer is also immutable. So float is an immutable type. Float is an immutable type, or what is that? Constant. Constant whose value is never changed. Float is immutable type or constant whose value is never changed. So Python allows to represent, Python allows to represent, okay, float values in two formats. Python allows to represent float values in how many formats? Two formats. Allows representing float values in two formats. One is in fixed format. Okay, or it is called as fixed notation. Fixed notation, and one more is exponent notation. Fixed notation, and one more is what? Exponent notation, exponential notation. Fixed format or fixed notation, and one more is exponential notation or exponent notation. How many formats can you represent float value? Two formats. After decimal point, whatever value you define, that you call it as precisions. After decimal point, how many precisions are there? Three precisions are there. What is this here? After decimal point, the values are called what? Precisions. After decimal point, the values are called what? Precisions. Array. Come on here. Fixed format or fixed notation. And second one is exponent format or exponential notation. So float data type, any data type in Python is unlimited length. Okay, so float allocates memory of what? Unlimited length. Unlimited length. There is no maximum size. There is no maximum size. For example, if you are working with a C language or C++ or what is that? Java. You find a float data type, but what is the size of float? 4 bytes. Okay. How many bytes of memory it reserves? 4 bytes. Means I can store the value of how many bytes here? 4 bytes. If I want more than 4 bytes, I'll go for which one? Double. So double is the data type, and this takes how many bytes? 8 bytes. But when it comes to the Python, okay, float. What is the size of float data type? What is the size of float data type? Unlimited length. Unlimited length because data is represented as what? Objects. And objects are dynamic. Okay, data is represented as objects, and objects are what here? Dynamic. Dynamic in size. Objects are dynamic in size. But in C++, Java, data is represented as scalar values. Means individual values, but it is not represented as what? Objects. For example, if you are talking about integer data types in C, Java, you find some data types like byte. So byte will take how many bytes? 1 byte. So there is a short, and short will take how many bytes? 2 bytes. Okay, there is a int, and int will take how many bytes? 4 bytes. Okay, there is a long. Long will take how many bytes? 8 bytes. But when it comes to the Python, how many integers are there? Only one integer type, and this integer type is with what? Unlimited length. This integer type is with what? Unlimited length. So this is comparison between the data types in C, Java and data types in what here? Python. So in C, Java, the data types represent scalar values. Data is represented as scalar values. In C, Java, okay, data is represented as what? Scalar values, individual value. But in Python, data is represented as what? Objects. And objects are dynamic. Objects are dynamic in what? Size. Objects are dynamic in size. Okay. Objects are dynamic in size. Because of that, is the size of the data types are fixed or unlimited? Unlimited. It is not fixed. It is what here? Unlimited, right? Yes, that is where you find the data types in C, C++, Java, and Python. Now, how can you create a float object? The float object is created. See, always the variables or the objects are created by assigning what? Values. How can you create integer? Sorry. How can you create an integer object? You can create an integer object by assigning which value? Integer value. A is a variable of which type? Integer. What is the value of A? 56. Okay, if I'm trying to say B equal to 78. Now B is a variable of which type? Integer type. I can say type of. I can say type of A. A is which type? Integer type. B is which type? Integer type. And every data type in Python is what? Class. So A is of which class? Integer class. B is of which class? Integer class. A is an integer type and B is also which type here? Integer type. Getting or not? Okay. A is an integer and B is also integer. But how can I create a float? I can say x equal to 1.5. X equal to 1.5. X is a variable of which type? X is a variable of which type? Float type. What is the value of x here? 1.5. 1.5. What is the value of x here? 1.5. So the default representation of float is in which format? Fixed format. Fixed format or fixed notation. Default representation of float value. Default representation of float value in which format? Fixed format or fixed notation. Fixed notation. Okay. So this is an example where I said x equal to 1.5. In fixed notation, there will be a decimal part and there will be a decimal part. There is an integer part. There is a decimal part and there is what? Integer part. And this is separated with what here? Decimal point. Now this is the integer part and this is what here? Decimal part. So 1.5. 1.5 is a value of which type here? Float type. Now suppose if I'm trying to say y equal to 1 point, so I can write how many precisions here? 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay, 1, 2, 3, 4, 5, 6, 7, 8, 9. So 1 point, 1, 2, 3, 4, 5, 6, 7, 8, 9. So how many precisions are there here? 9 precisions. For example, if I'm saying z equal to, okay, z equal to 1 point, okay, 1, 2, 3, 4, 5, 6, 7, 8, 9, and 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay, 1, 2, 3, 4, 5, 6, 7, 8, 9. Total how many precisions I've given? 27. I've given how many precisions? 27. 1 point, how many precisions I've given? 27. But when I print a z value, it is taken how many precisions? 1, 2, 3, 4, 5, 6, 7, 8, 9. 1, 2, 3, 4, 5, 6, 8. Total how many it is taken? How many precisions it is taken? 16. 16 or 17? Okay, 1, 2, 3, 4, 9, 10, 11, 12, 13, 14, 15, 16. Not from 0 here. 1, 2, up to 9. 9, 3. Okay. So total how many precisions it is taken? 17. Total how many precisions it is taken? 17 precisions it is taken. 17. But what happened to the rest of the things? It means always, okay, always it will try to, yes, just try to remember this. If you total number of precisions, 1, 2, 3, 4, 5, 6, 7, 8, 9, 16 only here, 10, and this is 4, 6, right? 16. Total how many are there here? 16. Okay, 1, 2, 9, 10. Then these are total how many here? 16. Okay, 16. Total how many precisions it is taken? 16. If you give more than 16, what is it doing? If it is more, if you give more than 16, what it is doing? It is trying to either truncate it It will try to either truncate it, either it will try to round it. It will try to truncate it, either it will try to round it to the nearest. It will try to round it to what? Nearest. But when will it do the rounding? It will do the rounding if it is greater than 0.5. If it is greater than or equal to 0.5, what will it do? Round it. If it is more greater than 0.5, what it will do? It round it. If it is less than 0.5, what will it do? It truncate it. For example, see here 9, 10, 11, 12, 13, 14, 15, 16. 16 is there. This is 16, right? Okay, so after 16, 16 means now this is 0.78. Is it 0.7 is greater than or less than? Is it 0.7 is greater than 0.5 or less than 0.5? Greater than 0.5. What it is doing? Is it rounding or truncating? Rounding it. So this 0.78 has become which one here? 8. For example, if I'm writing P equal to 1 point, okay, 1.123, 123, 123, 123. Okay, 123, 123. I'm writing like this: 123, 123, 123. Okay, so how many precisions I've given? 1, 2, 3. I repeated some. Okay, 1, 2, 3, 4, 5, 6. Okay, 1, 1, 2, 3, 4, 5, 6. Okay, 7, 8, 9. 9 times I repeated. Now, how many precisions I've given? 27. But actually, Python takes how many precisions? Only 16. Python takes how many precisions? Only 16. If I say print P, what it will print here? If I say print P, what it will print here? 1, 2, 3, 1, 2, 3, 1, 2, 3, 1, 2, 3, 1, 2, 3, and what? 1. Is it rounding is done or truncation is done? Truncation is done. Why? Because is it greater than 0.5 or less than 0.5? Less than 0.5. If it is less than 0.5, it will do what? Truncation. If it is less than 0.5, it will do what? Truncation. If it is greater than 0.5, what will it do? Rounding will be done. So same thing will happen when you go to hotel and if some coin, I mean, the bill, it will try to put either rounding or what? Truncating. Okay, if it is 1 point, suppose 1 rupee 57 paise, 57 paises will be there. No. Then what it will do? Round it. Round it to what? 2 rupees. Okay, that is different scenario, but just try to understand it. Okay, if it is greater than 0.5, what it is doing it? Rounding it. If it is less than 0.5, what it will do it? Truncate it. But how many precisions it will take? How many precisions it will take? 16 precisions. So number of precisions are not unlimited length. Number of precisions are not unlimited. Number of precisions are not unlimited. Okay. So Python reserves memory of how many precisions? 16 precisions. 16 precisions. If it is more than 16 precisions means after decimal point. Okay. If it is more than 16 precisions, it will do truncating. It will do what? Truncating or what? Rounding. It will do truncating or what? Rounding. It will do truncating or rounding. Yeah, that formatting you can do it. That is formatting. That is formatting. My value is having 1.123456789. If you want only 2 decimals, you can format it. That is formatting. We'll discuss that. Formatting. Formatting here, formatting outputs. That is different. That is formatting outputs. That is different. Okay, right now this is in which format? Decimal format. In decimal notation, or what do you call it as fixed format or fixed notation, there will be an integer value and followed by which one? Dot. There is an integer value followed by which one? Dot, and then followed by number of precisions. But you can also represent this in which format? Exponential format. Exponent format. Exponent format or exponent notation. Exponent format or exponent notation. Exponent format or exponent notation, right? See, you have to write in a program. Why? Because when you're working with the shell, right? Shell is a separate program. I said floats are shareable or not? Constants are shareable. Is it immutables are shareable or not? Yes. I said A equal to 1.2 and B equal to 1.2. If I say ID of A and ID of B, is it ID of A and B are same or different? Different. Because shell, because of this shell. But write a program. Write a program. So N1 equal to 1.2, N2 equal to 1.2, then print ID of N1 and print ID of, what is that? N2. Print ID of N1 and print ID of N2. You should work always in program mode. Is it IDs are same or different? Same. It means how many variables here? Two variables. And how many objects? One object. So don't see in ideally and tell that it is not shareable. No. So according to Python, all constants are what? Shareables. So Python means every Python application is executed by Python virtual machine. You have to work in which mode? Programming mode. You have to work in programming mode, but not in the shell, not in interactive mode, because interactive mode is not for developing applications or developing projects. You always develop a projects by writing a program. Okay, na? So don't think that it is not shareable like that. Okay. Okay. The next one is exponent format or exponent notation. If the value is very large, if the value is very large, if the value is very large, it is represented in which notation? Exponent notation. In exponent notation, okay, the float value, okay, uses one special character. It uses one special character called which one? E. E or capital E. So E is nothing but what here? Exponent. E is nothing but what? Exponent. The value of E is what? 10. The value of E is what here? 10. The value of E is a 10. The value of E is 10. So how you are writing this value? You are writing this value like this. For example, I'm writing N1 equal to some 125, okay, E to the power of some 2. Okay, now this is which value here? Float value only. But this float value is represented in which notation? Exponential notation. What is the value of N1? 12,500.0. So what is this 12,500.0? So this is nothing but 125 into 10 to the power of 2. What is the meaning of 145 into 125 into 10 to the power of 2? So 125 into 10 to the power of 2 is what? 12,500 dot 0. Dot 0. So what is the value of E here? 10. What is the value of E here? 10. Suppose if I am writing N2 equal to 125 e to the power of minus 1. 125 e to the power of minus 1. This is nothing but 125 into 10 to the power of minus 1. Is nothing but 125 divided by 10. 125 divided by 10 is what? 12.5. So what is the value of N2? 12.5. So what is the type of N2 here? Float. So you are trying to represent the float value in exponential notation. Suppose 12,500 e to the power of minus 2. Okay, 12,500 e to the power of minus 2 is nothing but 12,500 into 10 to the power of minus 2 is nothing but 12,500 divided by 100. And 100 means what is the value? 125.00. What is the value of N3 here? 125.00, which is nothing but 125.0. So what is the value of uh, what is the what is the value of E here? 10. What is the value of E here? 10. So in exponential notation, you are trying to use one special character. What is that special character you are using? E. So the value of E is a 10. Now how this is represented here is, okay, 125 into e to the power of 2 is nothing but 123 into 10 to the power of 10 to the power of what? 2. So 123 into 10 to the power of 2, 125. Sorry. What is my value? 125. Right. So this is how you are representing which data type? Floated data type. Okay. Yes. So integer numbers, and second one is which numbers? Real numbers. Integers, and second one is real numbers. And there is one more type of number which is called as complex. Now we'll be using all these data types while developing applications, right? So, but what we are learning is how to represent data by using different data types. How to represent data using different data types. So there is a data type called which one? Complex. Complex data type are complex numbers. Okay. Now this data type is used. Okay, this data type is used to represent which one? Complex numbers. So complex number. A complex number, a complex number consists of how many values? Two values. One is the real and one more is what? Imaginary. The complex number is having how many values? Two values. Okay. A complex number is having how many values? Two values. The first value is a real and second value is what? Imaginary. Okay, right? So it is having two values. One is real and one more is imaginary. Now complex class. What is the name of the data type? Complex. Complex class or data type is used to represent which numbers here? Complex numbers or complex object. Complex number or complex object. So what is the syntax of representing complex number in Python is syntax of representing complex number. Syntax of representing complex number. Now you are trying to represent a complex number in this format. So the syntax is real plus. Okay, first you are representing which value? Real value. And here the real and imaginary values are separated with what here? Plus. But in this case, plus is not called as addition operator. Okay. But here pluses act as what here? Separator. And you try to define which value? Imaginary value. You are separating real and imaginary values using which one? Plus. But always imaginary values suffix with j. Imaginary value suffix with what here? J. J. Imaginary value is okay. Imaginary value is suffix with. You have to remember. Imaginary value suffix with what here? J. But in mathematics, you'll try to use what? I. 1 plus 2i. You'll use 1 plus 2i. But when it comes to this Python, you try to use the suffix as what? J. And that J indicates which value? Imaginary value. Now this is a syntax of representing which number? Complex number. So, but you're separating this real and imaginary values by using one operator called which one? Plus. Okay. But whenever you are saying a complex, right? Complex number or complex data type or complex object is having two attributes or two properties. One is a real and one more is what? Imaginary. One is a real and one more is what? Imaginary. And here real and imaginary attributes are variables. I can say complex number object is created with okay two attributes. Okay, two attributes are properties. Properties are what is that? Variables. Okay, one variable is real, which is a type of float, and one more variable is imaginary, which is again type of which one? Float. So it means complex number is having two values. One is real and one more is imaginary. But these both are of which type here? Float type. One is real and one more is imaginary. And these both are of which type here? Float type. So it is created with how many attributes here? Two attributes. It is created with two attributes. One is real and one more is a imaginary. So we'll try to discuss about this, how to work with the complex data type and where exactly we use this complex numbers in application development, right? But tomorrow we'll see it. Today we'll just stop it here and tomorrow we'll continue with this complex numbers. And after complex, we'll see booleans and even we'll see non-data types and then we'll start writing programs. Okay, right. So tomorrow we'll see that. Today we'll just stop it here and tomorrow we'll continue. Okay, so thank you.